Alright, so this is another more advanced completing the square vertex form problem, where in order to complete the square, our a value, if it's not positive 1, we're going to have to factor something out again. So let's take a look at this one. Again, we're going to start by moving the 33 over. So y plus 33 is equal to the opposite of x squared plus 12x. Okay, and like last time we had to factor out that 2, this time we're actually going to factor out a negative 1 from each on this side. So if we factor out negative 1, that leaves us with positive x squared and minus 12x. And over here, of course, still y plus 33. Alright, and so we've set ourselves up where we can kind of complete our square now. So over here, we're going to have y plus 33. And again, I'm going to leave a little bit of extra room. We'll talk about how to fix this side over here. Equals negative 1 times the quantity x squared minus 12x plus blank. And that's where we'll be able to complete our square in a second. But here, when we do complete the square and add this new value over, it's really like negative 1 times that value. So rather than adding a value, it's more like subtracting this time, since it's negative 1 times it. So over here, we're actually going to have minus whatever that value is. So let's complete our square. So we need, here's our b value, and remember the one that goes here is half of b squared. So I'm going to save us a little bit of time here. Half of b is negative 6, and when we square it, we get 36. So that's the value we're going to add to each side to make that a perfect square. So over here, this is really a negative 36. And 33 minus 36 is negative 3. Over here, don't forget your negative sign there. This is a perfect square. It's x minus 6 quantity squared. And now this is pretty much in our vertex form. We're just going to add the 3 over. So we get the opposite of the quantity x minus 6 squared plus 3. And that's in vertex form. So our vertex is at the point 6, 3. Our a value is negative 1, so this graph is going down. And because it's a 1, it's going down in kind of our standard rate of a parabola.